Hello, everybody, and welcome to today's presentation, Ballerina, Cloud Native Programming Language, brought to you by WSO2. I would like to introduce you to our presenter, Anjana Fernando. Anjana is a key part of WSO2's Ballerina and ecosystem engineering team, where he spearheads efforts to shape the capabilities offered in the related technology areas. He has also contributed to WSO2's integration-related projects, including the Ballerina programming language in the areas of the VM, transactions, and data handling. He has carried out several on-site customer engagements, providing support for integration and analytics projects as well.
Great, thank you. Hi everyone. Welcome to this webinar on Ballerina, the cloud native programming language. So here I'll be talking about why we have created a new language, the requirement for it, and the history that led to this. So I'll be giving an overview of the features, and I'll also be doing some live coding in the process to demonstrate some of the features of the language. So let's get it started. So with the high customer demand, so this has led to the rise of companies like Google, Uber, and Amazon. So what they have done is they have created complex systems to meet this customer demand. And if you look at how these companies have evolved, what they have done is they have increasingly disaggregated their architectures in order to scale. So this is the trend we have seen throughout the decades. So massively disaggregated approaches like microservices, serverless, APIs, and so on are becoming the norm. So with these disaggregated components, we have seen these become network accessibles. So we call these endpoints. These can be data, APIs, microservices, serverless functions, and so on. So everything has becoming a programmable endpoint, and this number of endpoints are exploding. So nowadays, the apps we write increasingly depend on endpoints. And so simply, integration is the discipline of resilient communication between these endpoints. And this is not an easy thing to do. There are challenges like compensation, transactions, events, circuit breaking, and so on. These are all hard problems. So there are two main ways to do integration. So one is using configuration-based products, integration products like ESBs, BPMN, EAI, and so on. So these are mainly declarative DSLs, so configurations that users have to author. And the problem with this is, for developers, this is not much of an agile approach. So it doesn't give you the flexibility when it comes to much complex systems. When it becomes larger, these configurations become much more complicated. So it's not the preferred way that developers like to do the implementing of the logic and the systems. So the other end of the spectrum is using a general purpose programming language. So for example, like Java, frameworks like Spring, JavaScript, Node, and so on. So these provide extreme agility where you can do anything with the programming language, of course. But the problem is these are not integration simple. That means it doesn't have the high level concepts that you will need, like for services, resilient communication, and so on. So you have to write these from scratch in the code. And so this becomes unmanageable again when you do a lot of integration scenarios. So these two problems and the difference between these two scenarios, we call that the integration gap. So with our team's experience by doing a lot of integration projects, we have seen that each project either fall into either one of these categories. So there's no ideal scenario where you can do these scenarios. So what we have done is we have created Ballerina. So Ballerina is a programming language which is both agile and integration simple. Let's see how we have done that actually. So we'll straight away go to some sample code and see the general structure of a program and how the general operations are done when using Ballerina for creating a simple service. So here we will be using Visual Studio Code. Ballerina is supported in several IDEs. So one of them is Visual Studio Code. We also have plugin for IntelliJ IDEA as well. So here I'll be creating a simple Ballerina source. And what I'm going to create is an HTTP service. So this is a basic skeleton of an HTTP service in Ballerina. So in Ballerina, so the language is inherently aware of the network. So that's one of the main features of the language. So it has the high-level concepts like services, endpoints, communication resiliency, and so on built into the language. So let's see how we can create a simple service that will return a fixed message when we invoke it. So I just call my service the specific name, and these resources are individual resources that will make up our API. So this is the message that will go out to the user when we call this. So here you can see we have a compiler here. In Ballerina, even when we do the response from the resource, it's not the end of the resource execution. If we want, we can actually see whether the response have successfully gone back to the client and do any required operations as needed. Like in some of the other frameworks, these resources may be bound to a method definition and so on. When the return value goes, it automatically ends. So you don't have the ability to write some logic to handle the error. But here you actually have the option. So if you want, you can actually get the error and do some actions. So should we respond? So in this case, we'll simply ignore the response for the moment for this sample, but the best practice would be you will actually check for the error and do some action. So this is it for our definition. We'll save it. And let's see how we can run this. So we use the Ballerina command for this, Ballerina run. We give the file name. And this will compile the source, and it will check whether there are any services there, and it will basically run this service. So this is up and running. Can do a quick GET request for this and see what the response would be. So the first service context would be the service name, since we haven't given any special context. So it's a service name followed by the resource name. So we see here that we got the response by doing a GET request to our service. So that's basically how we would write a simple service in Ballerina. Let's see how we can do further more actions. So this is basically what we did, as shown in this sequence diagram. The next part is in Ballerina, so we can change the behavior of our service and the resources using annotations. So we can give some metadata on how it should behave and some additional information on customizing the service and the resources. So one of the things we can do is we can make it process post requests by considering the post data and do some action. Let's see how we can do that. So we'll go and update the XAMPP service. So here we will be giving a specific context for my service. This will be done using the HTTP service config, and we give the property base path. So I gave the root path as the base path, and my resource, I'm going to give a specific path. So for now, let's again, that also will keep it as the root. And the methods will only allow post to be done to this resource. So we can give an array of values here. So I'm only giving post as the supported operation. So here we will extract the payload that's coming in. So we call this function get payload as string, and you can see here again we got an error. So the what we return is not actually a string, but string or error. So in Ballerina we have a rich type system which also supports union types. So it can one can return multiple types together. So what we have to do is we have to extract the string by looking at whether there's an error or not, or we have to get it and we have to see and act according to the type. So we can do this by doing an if name is string. If it's string only, we do a response. Okay, so here again we got another compiler, and it says tainted value passed to sensitive parameter message. So in Ballerina, so we have a we have a system called taint analysis. So it's a built-in security mechanism that is there in Ballerina. So this does static analysis on the variables to see whether we are using unsecured data in secure environments. So we have marked these payload values and so on as tainted data. So if these values are used in a secured environment, like this response operation, we won't let the developer do that unless they explicitly tell to the compiler that this is safe, or they clean the value and then use it. So one way of cleaning the value or instructing the compiler this is fine is using the untaint operation. So we have done that. So this is it. So this is the updated service. Let's see how this is executed. Okay, the service is started. Let's do a curl request to this as a post request. Okay, I'm giving a name as the payload. So our context is, so the service is root, resource is root. So we just have to send it like this. So you can see here, so we got the response back saying hello Jack. So by looking at the post payload. So we saw now how we can use annotations to augment our service, its behavior. And let's move on to some of the other features. Another main aspect of Ballerina are connectors. So as I mentioned earlier also, Ballerina is very aware of the network. So for integration scenarios, so we mostly work with services across the network. So it's a natural aspect that the language also knows about the network and knows about the network communication that is done. So because of that, we have a special entity called connectors that are there in the language, which are identified by the runtime as special operations. So with this, we can apply security, observability, and so on, especially to these actions. So let's see an example of how the connectors are used in the system. So this is the demo we will be doing. We'll be having a service called the rec service, and that service will be getting some binary data, and we'll be calling the Amazon recognition service using a connector we have for operating with this service. Let's see how this is done. So let's update the same example we had earlier. We'll just do quick update on the code. We'll actually give a specific context here. Say it's action. We'll keep we'll keep it as a post request. So the first thing we'll be doing is we'll extract the actual binary data that will be sent to the service. Go to the input. Get the binary payload. So also these resources we can also mark as returning an error. So if you want to signal to the system that you should just handle it, log the error, and so on. So we can say it returns an error. With this, we have a special operator called the check operator, where in any expression, if there's some value or error, it will basically extract the error out and return it from the function. So from this function call, this returns an error or byte array. So for if something goes wrong, if an error comes, this will immediately, that value will be immediately returned from this resource. So this is basically a shortcut to handle that situation. So that's how we got the byte, the binary data from the request. Now let's initialize our connector we are going to use. So this will be the Amazon recognition connector. We start by initializing the connector configuration. So there are two properties, access key and secret key we have to give. We get these values using our config API. These configuration values, the keys are there in this file called Ballerina config as two properties. I'll be reading those using two string values. So that's the configuration. Now let's initialize the connector itself. Initialize using new by passing in the configuration. Okay, now we have the client initialized. Now it's just a matter of calling the client. So we will be calling an action called detect text by giving the binary value. So this will return a string or an error. So we will be getting the value here. So you see that there's a special notation to call actions in our client connector. So an action is something that happens through the network. So this is where we give a special recognition to the network interactions that are happening through Ballerina. So we have to see whether the value is a string. If it's a string, let's write it back. For now, let's ignore if there's an error comes from the response. Oh, actually, since we say we are returning error, we can do a check here. So if there's an error happening in the response, it will basically return the error from the resource. Also, if we got an error here, let's just log it here and return that as well. So this is it for our service, which calls an external service to get something done. Let's run this and see. Okay, so it's up and running. So for this, the binary data we'll be posting would be this image that's here with some text. So our service is calling an actual OCR service in Amazon. So ideally for the result, we should be getting this content as text. let's see whether it works. So context would be action. Yeah, so you saw like how the binary data is sent to our service. It's relayed back to the external service that is there, and we got the response back with the actual detected text. So that's it for that sample implementation. So let's back to some of the other features of the language. Being a cloud native programming language, so we have built-in support for Docker and Kubernetes as well. So when we have Ballerina services, we can quickly Dockerize them, create the Docker images, and deploy them in Kubernetes by actually adding some annotations. So you don't have to change any code logic or any additional code to make this work. Just by annotating our services, you will be able to automatically generate the deployment artifacts, the YAML files needed to deploy to a Kubernetes cluster. Let me quickly show this how this works with our sample as well. So the first step is in our service, we have to say we have a specific deployment, a Kubernetes deployment. So this will import the Kubernetes module. So we basically annotate this as a Kubernetes deployment, our service. And also, if we have any listeners, so these are the listener endpoints we had. So here we have inline the listener. When we are deploying it in Kubernetes, we have to annotate that as a Kubernetes service. So to get our traffic into our Ballerina service. So let's externalize this. Let's see how to do that. So we are using the listener keyword. Let's give a name to that. Okay, so we have created the listener and we have to just mention that here, the service. Then we have to annotate this listener with a Kubernetes service annotation. And here we can say the service type is, for here we'll just use node port. You can use other values like load balancer and so on when you want to get an external IP. Then those are the main annotations you will be needing. So for our scenario, we also have some configurations that are required for our service to work, the service credentials. This will be done by associating a config map with our Kubernetes attributes. So here we give a Ballerina config here. We say what's the Ballerina config file, and this will read in the config properties and create a Kubernetes config map. So this is all we have to update. So we have the deployment annotation, config map, and a service for our listener. Now what we have to do is, let's go and build our service. So all this time we use the Ballerina run command to build the program and execute it in one go. So we can also use the build command, which will build the executable and any other artifacts that will come by building the Ballerina source. So we'll be using the build command. So here you see here there are some additional actions that are happening here. This is done by the compiler, where they see the special annotations that are there in the code, and they do some additional actions to create the Docker image, the Kubernetes artifacts, and also our Helm chart as well. So you can directly deploy this to a Kubernetes cluster. So I have Kubernetes running locally in my computer. So at the moment I don't have anything. So I'll be running this command and deploying our artifacts. Now this has been deployed. You can see the service running here with this port. So let's execute the same command, our earlier curl command, to the service that is running in Kubernetes and see whether it works. So we have to update the port here. Okay, so we saw that we got the same response. That means the actual request went onto the Kubernetes cluster, the service there, and it returned the response. So you saw how quickly and easily we can turn a simple Ballerina service to be able to deploy it to Kubernetes. Also, another rather recent addition we have added to the deployment is the AWS Lambda support. So here we can simply get a Ballerina function and turn it to a Lambda. I'll do a quick demo on this as well. So I'll be creating a new source file. So there's a specific module that we have imported AWS Lambda. So I'll be creating a simple function that will return an UUID. So the function has to be there with a specific signature that represents the Lambda context and the input and the response. And the main thing would be we have to annotate this with the AWS Lambda function annotation. So that's it. Let's quickly build this and see what happens. So with this, we are presented with some specific instructions on what to do. What has happened was, so with this, it automatically created this zip file with the AWS Lambda, the binary. This is the zip you have to just upload to AWS Lambda environment to be able to execute that as a function. So this build command have given you the sample commands that you have to run with placeholders for the function name and so on, and your user role, which has the required permissions and so on. And also there's a specific Lambda layer you have to use with each specific Ballerina release, so which you can find here. So the link is also mentioned in the build command. Let's quickly deploy this and see. I already have the commands with the placeholders filled in. So I already have this function. Let me quickly delete it. Okay, so deploy that again. Okay, that created the function. Let me associate our Lambda layer with that. Okay, so now our Lambda function is fully initialized. Now it's just a matter of calling that. Can use, so I'm using the AWS CLI tools to do this. Lambda invoke. There is the name. Output content would be there in out text. Immediately printing out the contents of that file. So you'll see the response of the Ballerina function. So here you can see that's the actual response that we got from the Ballerina function. So the first request takes a bit of time, then because of the cold start, then it happens instantaneously. So you saw how easily you can deploy a Ballerina function as an AWS Lambda as well. So let's move on to another feature that's there in the language. So we have built-in observability features from the language itself. So I have shown you like that we have special operations like the network actions, services, and so on. Because the runtime is aware of these operations, we can do automatic observability for these aspects. So whenever you do a remote call action, these are automatically observed, and the metrics are gathered, and the tracing operations, all these are executed automatically. So you don't have to write your own custom code to get these done as well. So for distributed tracing, we're using the Open Tracing Standard. So you can interface an open tracing provider like Jaeger, Zipkin, and so on to get the tracing done when you have like multiple microservices where the requests jump through multiple hops. You want to see where it has gone, performance bottlenecks, errors in the flow, and so on. This can be done with the tracing features we have. Also, metrics are supported by Prometheus and visualization with Grafana. So you can configure Prometheus server to pull the metrics from our Ballerina runtime and to visualize some of the built-in metrics that are available in the runtime. Also, there's a user API as well if you want to further extend these features for your custom metrics as well. So logging, so we have our logging APIs that we can use in Ballerina. So for custom logging, as well as the default logging features that are there in the runtime. For example, transport, like debugging and so on, we have like HTTP via logs support and so on, which you can directly use in log processing frameworks like ELK and so on. Also, we have full Swagger support, where you can create like Ballerina stub skeletons using a Swagger definition, Swagger Open API standard, and also from the existing services that are there in Ballerina, we can also get the Swagger definition as well. Also, another main aspect of the language is we call it sequence diagrammatic. This is where the Ballerina language is designed to be compatible with the sequence diagram view. All the language concepts and the features are designed around this concept to be compatible with this concept. Like when you have a complicated scenario, we always use like a sequence diagram to show the interactions, the parallel executions, the actors, and so on. So what we have done in Ballerina is we have made it compatible to this view. So we can like create a seamless view of our system using the code without any actual user intervention. So I'll quickly show this view from the demo we created earlier. So you can get this view by clicking this icon in VS Code. So you can see here, it automatically created the code, the graphical view, by looking at the code. So you see here the actors like the client, the remote client connectors, the call and so on are properly mentioned here with the remote actions, interactions represented here as well. So any code you have here, it will basically automatically update this view, as you can see here. So this is very useful where you have basically self-documenting code with the Ballerina diagram view. So this is a high-level view of the ecosystem extensions we have around Ballerina. So these include the compile extensions, the connectors, deployment options that are there. Where we went through some of these in this session. So finally, Ballerina is a fully open source project. So it's licensed under Apache 2. You can find it in GitHub under the Ballerina platform repository. You can get involved with the development and the design discussions, implementation as well. So everything is open. And to learn more, you can go to the ballerina.io website, where we have lots of content there on example, guides, and references on how to get things done. And of course, if you have any specifications, you can ask in Stack Overflow as well by tagging with the Ballerina tag. So yeah, I encourage everyone to go and check it out, download the distribution, run some programs, do some coding, and see what's like how the difference it makes compared to your day-to-day programming in the current languages. So that's it for my presentation. I can take in some questions if there are any from the audience.
Awesome. Thank you so much. We do have a couple questions that have come in. The first question that we have is, what is the language that Ballerina is coded in?
Oh, okay. So Ballerina. I think the question is, so Ballerina is like a whole new language. So it's not based on any single language. Um, we are inspired from many technologies and languages like starting from like Go, Rust, Java, C++, and so on. So it's not a single um, language that we have used as the base, but we are actually inspired from many tools and technology and languages that are out there. Yeah.
Great. The next question that we have is, what are the main advantages of Ballerina over Spring Boot?
Okay. So yeah, Spring Boot again. So Spring Boot, we use the framework on top of Java. So it's like a bolt-on framework to get the language to do certain things that we want, like do the integration, the services, and so on. So what Ballerina did was, so this functionality, we don't have it as a separate library, but rather, or library or framework, but rather we got those features and the concepts into the language itself. So it's a first class concept in the language, like the network awareness, communication resiliency, security, and so on. So the main aspects that we need nowadays when we are writing these complex distributed applications, we got that as part of the language, because we saw that those are the things people will mostly use. They should be first class citizens of the language we use. So that's the main difference. So it's not like an afterthought or a bolt-on framework that we use later, but it's just there with the language you use.
Great. The next question that we have is, why should I learn Ballerina when I can use different libraries and other languages to do the same thing?
Yeah, so I think that again is a similar question. I think the same explanation will apply. So again, so what we have done specially in Ballerina is we have got we have checked the main use cases now people use when programming complex systems like distributed systems and so on, and we have made that as native things in the language. So main thing is the network awareness. So Ballerina is by default network aware, and other things like we have a richer type system that again is network compatible. Like we have a structural type system compared to a nominal type system that are there in other languages like Java, C++, and so on, which makes it more network friendly when doing network communications and so on. So that's the main difference. So our differentiation is so we have put some of these useful features and concepts into the language itself rather than keeping it too much of a general purpose language. So it is a general purpose language, but with some specializations like some modern features that are required for the operations we do nowadays.
Awesome. The next question that we have is, from which language is Ballerina based on?
Yeah, I guess it's the same exact question that was asked earlier. So again, it's not a single language. So we didn't take one language as a base and worked on it. So it's again multiple concepts of from various different languages and tools. So we thought like some of the features that are useful here, the features that work together to be put together, and some of our own innovations as well brought into the new language. So it's again not from a single one, but from multiple tools, frameworks, and our own ideas as well that resulted in Ballerina.
Great. We do have a couple more questions. The next question is there a Ballerina equivalent description of the enterprise integration patterns?
So you can do all of the enterprise integration patterns using Ballerina. We haven't actually documented them each one by one. But if some of these are covered in our guides, so we have something called Ballerina by guides in our ballerina.io website. So if you go to ballerina.io, Ballerina by guides, you will see several scenarios that cover these enterprise integration patterns. So you can use those as the base and map basically all the enterprise integration patterns and get it done using Ballerina. So yeah, so BBGs would be a good place to start.
Great. We do have one more question. The last question is Ballerina production ready?
Yes. So Ballerina, so we have been developing it for several years now. And we have a few production customers for the language that they are using in production, and the language is more or less stable now, specification wise. There will be slight deviations or slight updates to the language going towards 1.0, but it is production ready, and we again have many users using them, and also we do monthly releases when it comes to bug fixes and incremental improvements to the language and so on. But yeah, you can certainly use the runtime in the language and the runtime in a production scenario as well.
Awesome. We did actually have one more question come in. That question is, what is the current time frame for the 1.0 release?
Okay. 1.0. So again, 1.0 doesn't mean we need 1.0 as the stable release or the release that you can actually go to production or anything like that. So 1.0 is at the moment planned for Q4 this year. But we have some other milestone releases or main releases also coming up. Our Ballerina 995, which is due in Q2 this year. So we expect somewhat little changes and even most probably backward compatible changes from 995 leading up to 1.0. So the simple answer would be the current time frame for 1.0 would be Q4 this year.
Great. Well, I'd like to thank you, Anjana, for a great presentation today. I would also like to thank today's sponsor, WSO2, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day. We'll see you next time.
Thank you.